off we go. Take it away, David.
All right, thanks, Roberta. I really appreciate it. Good afternoon, everybody. Thank you for tuning in. And give me just a second here while I get my screen shared up and running with all of you. And start this from the beginning here. All right. So this is going to be a webinar on essentially fire mitigation and risk reduction. I am going to hopefully focus on the structural ignition portion of it, but that involves understanding a little bit about some of the history and background of wildfires as we move along. So without further ado, for those of you who may not know who I am, I worked with CAL FIRE for 32 years. I ended up about the last 5 years of my career, I worked in a state fire marshal's office in Sacramento. I was the staff chief for planning and risk analysis, which oversaw the strategic fire plan for the state of California. Prior to that, I'd been mostly in the Sonoma Lake Napa unit. I started out as a seasonal firefighter up at the Sea Ranch in Sonoma County, so very familiar with this area and the fires that we've suffered through recently and things like that. I did spend 11 years of my career on one of our incident management teams as the public information officer. So I've dealt with a lot of large fires across the state. I've worked as the fire marshal for Napa County. And I also have a degree in architecture and practice as an architect before joining the fire department. And so I have a unique background and understanding of structures and their ignition potential, and that's what we want to talk about. So essentially, we're looking at a global problem, not just a national problem, certainly not just dedicated to the state of California, but how do we address the problem and move forward? So that's really what we want to start with. And before we get started, or as we get started, I want to make a couple of assumptions as we move forward. First of all, we all have to agree that California is a very natural fire environment. Fire has been a part of the ecosystem here in this part of the world for millenniums, long before human beings ever populated this part of the planet. But over the last 100 to 200 years, land management decisions and human intervention of fire suppression has dramatically altered the fire environment that we now find ourselves in today. And we'll get into a little bit of historical perspective on that in just shortly. The fact that we've altered the fire environment have resulted in creating a very unnatural environmental state. And we recognize today that things have to change, but there's a lot of disagreement and not a lot of consensus on how we learn to live with fire and how we do that. So that's one of the studies that we're going to talk about. And how do we move forward with trying to understand that as a more collective agreement. So first of all, we're going to look at California's fire problems specifically. California has what's referred to worldwide as a Mediterranean climate. Obviously, that climate comes from the vegetation and weather patterns that we see across the Mediterranean, Greece, Portugal, Spain, Italy, the southern part of France, all those kind of things where there is a very productive growth of fuel. They have very critically dry summers every year. And that hot and dry condition goes ahead and slowly decomposes the fuel and provides a very prime landscape for fire to occur in. And in California specifically, we look at over time, that fire environment has changed dramatically. If we really look at pre-1850, this is right at the time of the gold rush, they estimate, the scientists look at the approximately 4.5 to 12 million acres burned every year. That's a lot of land. That's way more than we see every year now. And that in the years prior to 1850, approximately that 100 years window between 1750 and 1850, fires occurred across the landscape at approximately, about every 3 years. And then the gold rush happened and we had a flood of people moving into this area. And it really created the collapse of indigenous burning, Native Americans who had been very good at using fire as part of their culture and part of their ecosystem, really went away at that point. About between 1850 and the end of the 19th century, fires started occurring about once every 12 years. And then from about 1897 to 1910, there was a very active progression of fire suppression that began. 1910 is really the demarcation year that we know of as kind of the time when things really did change. Because in 1910, there was, that year was an extremely dry year, and there were fires throughout the western United States that erupted, burning millions of acres, not just in California, but across the entire western United States. And the fires were so, huge and so severe that they found ash and smoke actually impacting New York City and Washington, D.C. And as the western United States was beginning to grow and the population was expanding into the western United States, there was a lot of frustration with this problem of wildfires that people were encountering. And if you think about it, back then at the late, 19th century, early 20th century, civilization existed in this mindset that they really thought that with the Industrial Revolution coming around, that mankind really could bend Mother Nature to their will. And the fact is that we now know, of course, that we can't. But the thing is, in 1910, as that fire really exploded across the western United States, the frustration grew and grew, and people said, we're really tired of this. We need to put fires out. And the problem is we got very, very good at it. So what happened is that there were a lot of land management decisions that came out of that big blow up in 1910. And this is a series of photos that were taken in Montana, but this is very, very typical that occurred across the western United States. If you look at that photo in the upper left-hand corner that was taken in 1909, just 1 year prior to that big blow up in 1910, you can see this almost beautiful park-like setting where there were, it was a very open space that, people could travel through very clearly. Back then, trees per acre were, counted in the tens, maybe 30, 40, 50 trees per acre. If you go to 1938, you're beginning to see the overgrowth because fire had now been removed from the landscape, and there were fewer fires keeping that vegetation down. 1958 and 1979, you can see these are the same photos in the same location, but look at that in 1979, 80 years later almost, that we have almost a complete obscuring of the landscape. And this is typical that occurred over time. And now there's 300, 400, maybe even 500 trees per acre that have occurred where it normally would have been 10, 20, 30 acres, trees per acre. So we've seen this massive change in the environment. And coupled with that, we have the Smokey Bear campaign. And I like to make an argument that Smokey Bear campaign, may have been one of the most successful ad campaigns ever in the history of the world. But there were some unintended consequences about that, because as much as we all love Smokey and as good of a job as it did of convincing the public that, we needed to be very conscientious about not causing unwanted fires in the landscape, what occurred is that it kind of brainwashed the public into thinking that all fires are bad, and that just isn't the case. In California, we have the Strategic Fire Plan, and I'll just read through. This is the vision of the California Strategic Fire Plan. It's a vision for natural environment that's more fire resilient, buildings and infrastructure that are more fire resistant, and a society that is more aware of and responsive to the benefits and threats of fire, all achieved through local, state, federal, tribal, and private partnerships. Now, the Strategic Fire Plan was just updated in 2018. And if you go on the website of either the Board of Forestry and Fire Protection or CAL FIRE, you can search for the Strategic Fire Plan, and it is the roadmap for how California is looking at dealing with the wildfire environment. Another thing we need to look at that's contributed to this is the drought and climate change. So, fire ignitions continue to increase above our 5-year averages. Obviously, we've seen more large devastating fires, the Valley and Butte fires back in 2015, of course, the Tubbs and Atlas fires in 2017, the Thomas Fire, the Carr Fire, the Mendocino Complex, of course, the Camp Fire in 2018, and the Kincaid Fire in 2019. There are on average 200 to 300, sometimes even more initial attack fires each week. Most of them you never hear of because they're kept at very small acreages. The state's goal is to keep ignitions of fires at 10 acres or less. 95% of those are done. Actually, we're maybe up in the 96, 97% of fires that start are kept below 10 acres. But it is that 2 or 3% that now exceeds those 10 acres that are causing the big problems. The other thing, of course, is that climate change has increased the amount of time that fire season dries out the landscape. So on average, we now see the fire season, that we call it, about 75 days longer than we did 40 years ago. And we all know that the status quo of just doing the same things that we've always done simply won't solve the problem. We need to start focusing our efforts on more fire prevention and attempt to be more proactive about it. But we also need to understand that the scientific research and the studies that are being done are teaching us much more about how fire behaves and the impacts to structures. So those are the things that we have to be more aware of and proactive about. These photos were taken just recently during the vast bug kill, the bark beetle, the tree mortality issues that occurred on the western slopes of the Sierra Nevada hills. And this was typical over the period of only a few years. There are now over 150 million standing dead trees throughout the Sierra Nevadas. And those trees continue to become more and more prone to wildfire ignitions. So you can see the problem in that lower left-hand photo there. If you live in that house, how do you deal with these problems around your landscape, and what do you do about it? So California has always had large fires. Again, we look at the millenniums of the landscape learning to live with the fire environment. But statistically speaking today, this is the actual statistics that have been pulled off CAL FIRE's website right now. This is current as of this week, that if you look at the interval of fires that from January 1st through May 10th of 2020 this year, we have 1,135 fires, which is above our 5-year average and almost twice as many as we had during this same time last year. The acreage is slightly higher than last year, but well below the 5-year average. But that was expected because, as we all know, here in the Northern California area, we've had a much wetter month of, these recent rains that we had in April and May have really brought about much higher moisture content. So even though we're getting more fires, the acreage isn't increasing as large, but we believe that, the forecasters are all estimating that the recent rains that we've had are now coming to an end. And we probably, as we all know, probably won't see any more fires until September, October, November, maybe even December. So those, wet conditions will dry out very quickly. When we look at the most destructive and also the largest fires, we look at the vast majority of them. If you look at these most destructive, 75% of them, 15 of the top 20 have all occurred since the year 2000. So we look at just 20 years of the largest fires or the most destructive fires have all occurred in very recent times. And we all know that because we lived through it. When we look at the largest fires, the same statistics are taking place, so that we're looking at these large fires that are occurring more frequently, sooner, more close together. So we've entered into an era of what we call these mega fires. And there's been TV shows about this, and you know, unfortunately, those of us here in Northern California have lived through these things, you know, in the last few years. So we are seeing more of these things happening. When we look at the statistical analysis of the number of structures, these are numbers only through 2018. This doesn't include the statistics for the Kincaid fire. But if you look at the number of structures that have been damaged or destroyed, our numbers are up over 40,000. In fact, the number is close to 42,000 at this point of the structures damaged and destroyed. And of course, you can see the vast majority of those structures are destroyed. And so the number of structures have continued to rise. So how do we go ahead and combat that? We first of all have to understand that the reason why these are happening, we get these severe fire conditions, of course, the Santa Ana winds in the south, we call them Diablo winds up here. What happens is if an ignition occurs and a wildland fire starts, in those severe conditions, we get very rapid spread of high intensity fires that very quickly, if it burns into an urban area where there are lots of structures, we get multiple simultaneous ignitions all happening at the same time. What happens is that, of course, that overwhelms the fire suppression forces very, very quickly, and they can't do anything to really stop the fire because there's too few resources, which results in reduced fire protection. Because we simply don't have enough engines to fight all the ignitions that are occurring, which ends up turning into an urban conflagration and a disaster where many, many structures are destroyed. And unfortunately, we're seeing more lives destroyed also. But what happens is that if we go back to the wildland fire that starts, the key is going to be looking at that third box up there, where now we see multiple simultaneous ignitions. If we go ahead and look at that as saying, what if we look at a future where structures become more resilient and we reduce the number of ignitions occurring, then the fire suppression forces could come in and start working on the fire without as many structures burning, and we have many, many fewer structures lost to that fire. And so what we do is, of course, we get to Paradise, the campfire, of course, on November 8th of 2018. And as I say to many groups, so far, that is the worst we've seen. But it brings up the question, do we think that we're going to see worse than this? And the answer, of course, is yes, absolutely. There's going to be more fires burn that are worse than that. Because if you say that it's the worst that we've seen, then you have to assume that that fire is the worst it's ever been, and then things are getting better from here on out. But quite literally, if you look at the fire research community today, you won't find any researcher or fire expert in the world, literally, that would say that we have peaked and things are getting better. In fact, if anything, things are getting worse. The photo that you're looking at right now is a history map that includes the campfire. And you see right there in the middle, that kind of green area that is the city limits of the town of Paradise. You know, it burned right there in the middle of that. It's a little difficult to see in this map because the campfire itself is this red outline. You can see a red perimeter that goes around there. And that red perimeter encompasses the footprint of the campfire as it burned, with Paradise right there in the middle. The actual ignition point for the fire started up in the upper right-hand corner of that, as we all know, from the power line that was down in the canyon of the Feather River. But if you lived in Paradise, this map shows a history of fires that had burned there before this. And if we look at all the previous fires, the Tubbs fire, the Atlas fire, all these big fires that we've seen recently, they're similar to this, where we have lots and lots of fires that have burned historically in this area prior to the history of the campfire burning. And so people were well aware of the fact that fire burned there fairly frequently. And so it wasn't unusual to see fires in these areas. But of course, unfortunately on that day, everything took off in an exacerbated state. This is the actual footprint of the campfire itself. You look at that blue kind of streak that starts there and goes kind of up to the upper right-hand corner. You'll see a little town, a little community called Polga. And that little town is just to the south west of where the fire started. But primarily, if you look at that blue color that then starts bleeding down towards green, and it goes down towards Highway 99 as you get towards Chico, all of that blue area burned within the first 12 hours. So in less than 12 hours, we had almost 60,000 acres of fire that burned in just 12 hours. And of course, Paradise was in the middle of that. They were making their announcement for evacuations. The fire started at approximately 6:30. By 8 o'clock that morning, they were already beginning to issue announcements for evacuations in town. And so that tells you how fast the fire spread. But any of us who've lived through most of these recent fires, we see that same kind of history beginning again. And again, you know, these photos of destruction are becoming all too common, that we're seeing. These particular ones are in Paradise. The right-hand photo is the Paradise Elementary School. This was a home actually in Paradise at the Ridge where somebody had built their house out of concrete and had actually even used steel studs to build the house with. But unfortunately, they had used a wood frame roof, and we do know that that fire started along the wood frame roof and went ahead and was destroyed. These are photos that were taken in the 2017 fires, some of the evacuation shelters, one of the wineries that was destroyed, and of course the Kmart in Santa Rosa from the Tubbs fire. But one of the questions is, how do we combat all this? And where's the, you know, is there a silver bullet out there? I'm going to give you the answer really quickly, that there is no single silver bullet to solve this problem. There's a multitude of things that we can do. Jack Cohen, who is a famous researcher that recently retired from the US Forest Service, had a very famous saying that I really like a lot, and says wildfires are inevitable. They are a part of the natural landscape. They have been a part of the landscape in California for many, many millenniums. But wildland urban disasters don't have to be. And that's where we really need to take some of these observations and start thinking about this. We don't have a wildfire problem because wildfires are a natural part of the environment. We just happen to be choosing to live in the middle of it. What this really is we need to think of it as a structure ignition problem, which really points back to the fact that we need to understand how to combat that structure ignition. When a vegetation fire starts, everything is fuel to it, whether it's vegetation, structures, vehicles. All of these things are just nothing more than fuel to the fire. And we're never going to fix the problem by just hiring more fire fighters and buying more fire equipment. That's going to help, of course. I mean, we have to rely on a very strong and robust firefighting system, of course, but we really need to start looking at how we understand the difference between the hazards that exist and then reducing the risk of those hazards so that it ignites fewer structures. And again, as I said, there's no single solution to all of this. Wildfire is very complex, and there's a lot of issues that we need to discuss. But one of the things that we do know, of course, is the ember problem. We know today that embers are perhaps the single most predominant factor for structures destroyed in wildfire. In fact, if we go through here, statistically speaking, the evidence is showing that between 80 to 90% of every structure that is either damaged or destroyed by wildfires is directly the results of embers. And I'll say that again, 80 to 90% of every structure damaged or destroyed by wildfires come from embers. It's not the direct flame exposure of the wildfire. It's not from radiant heat. It's from embers. And so If we have embers igniting a structure fire, that all the data that we have that I showed you earlier, that is the number of structures damaged or destroyed. If a structure ignites by a wildland fire today, it has less than about a 5 to 10% chance of actually surviving the fire. So the research is being done, and this photo is actually from the Insurance Institute for Business and Home Safety. It is a testing lab back in South Carolina where you can see that they have simulated a wildfire event blowing embers at a structure and watching how those embers are igniting structures. So we understand the fact that embers are causing the largest number of ignitions on structures. So are we really emphasizing this enough? Again, some of these photos and different shots from the IBHS lab in South Carolina. And so how do we look at creating a more resilient structure and communities as a whole? First of all, you have to understand that there's essentially 3 ways for a structure to ignite. As we just discussed, the wind-blown embers, by igniting the structure directly or igniting something right adjacent or on the structure, is going to be the vast majority of ignition sources that we find in wildfires today. But there is radiant heat. If you are very close to a neighboring structure that ignites, the radiant heat from that burning structure could ignite your structure if you don't have enough resiliency to resist that radiant heat. And then again, on rare occasions, a very limited number, we have actually direct flame contact that can come in contact with structures and potentially ignite a structure, but that's very, very rare. So how do we survive, how do structures survive a wildland fire? We have to look at both the vegetation and combustibles on the property itself, as far as what you have on the property, the selection, location, and the maintenance, your defensible space, all of those kind of things that you're looking at that we're very familiar with. We've been talking about defensible space now for decades, and we are very well educated in that. And it's very important to make sure that you understand that that is a very important component. But we also have to look at the home construction itself. We have to look at the materials that are made, that structures are built out of. We have to look at the design features and how that structure could face an ember exposure and how that structure can resist those embers actually igniting the structure. So one of the newer ideas that we have that we know a lot more about today is what is called the non-combustible zone. And when we look at, say, a 0 to 5 foot perimeter around the base of a structure, if you think about embers igniting landscaping or vegetation of any kind, or debris, or let's say your wood pile for your wood stove or something like that, even furniture on a deck or things like that, if anything around the edge of that structure that ignites has the potential of igniting a structure. And so we're going to talk a little bit about how to resist that and how to, some of the concepts about reducing the amount of combustibles right around the base of a structure. We also have to look at code options. Now, California still today is the only state in the entire country that has a statewide wildland urban interface code. It's Chapter 7A in the Building and Fire Codes. And those options that we look at are proving to be very, very beneficial. And we also have to look at the cost of all of this, because we know there are costs involved in upgrading structures to become more fire resilient. And not everybody's going to be able to afford to do those right away. But of course, you have to look over time at being able to plan and budget for things to be improved. When we look at communities overall, we want to look at community planning. Can we restrict building in fire-prone areas? Are we really building in the right places? What do we have to do about existing communities? I mean, we know about areas that we've built in, and You know, that question has been asked over and over and over again as we've seen more fires burning in areas. You know, are we building in the right place? Can we restrict these areas? Can we do smarter land use planning about where we put structures in the landscape? The answer, of course, is yes. And we can you know, looking at the long-term resilience of structures and communities, we can do a lot better job than we have in the past. As far as communities go, do they have a good warning and evacuation plan? You know, have they conducted drills to plan those evacuations? Do they have a reliable alert and warning system that has been tested, that people know how to respond to it? Traffic plans, backup plans when the lead times are short, the evacuation routes for getting people out, and the ability to move people. Of course, we've seen all of these as challenges that we've seen in recent fires, and how we get people out safely with very, very little time. So we're learning more about it. But as we begin to move into the future, we're looking at, you know, again, are there ways to build structures in ways that will be more fire resistant? This happens to be a new type of construction panel that is high insulation quality that will be covered in concrete, making it virtually impervious for embers to get in and ignite anything on fire. So there are new construction techniques that are highly resilient to embers, and we need to be paying more attention to that. We need to be paying more to the home ignition zone, so that we are looking at the surroundings that determine whether a home has a likelihood of igniting from a wildland fire. We need to be paying more attention to this zone right around a house. This actually, the left and lower right pictures is a picture of a home in Paradise that actually survived the fire when all of its neighbors were destroyed. There were a number of things going on about this. This was a newer home that was 1 year old. You can see that it had fire-resistant siding. They had the fire-resistant landscaping around it, the vents, the windows. Everything was done so that it was highly resistant to ember ignitions. And we also find that it doesn't show up very well, but the lower picture on the right is a rocky outcropping that helped divert the fire around that structure. And so by placing that house on that particular spot, it actually helped, as the fire burned up that canyon, to divert the fire around it. So there's many things that we can do when we look at the landscape about deciding and choosing where we place a home on a piece of property to help reduce it. And again, you know, if we educate the public in doing maintenance around structures, here's just a typical shed that somebody has that they just went through the process of cleaning up the stack of combustible materials that you can see on the right photo after it's been cleared up. You've really, really removed the likelihood of the embers igniting that structure. Again, we look at, this is another photo of a structure in Magalia that occurred during the campfire. And this structure actually, if you look at the right-hand photo and the gutter that is down below, the gutter was actually beginning to burn with embers and things like that in it. But the fire department came through, and we know this because there were people that saw it. The fire department saw the gutters starting to burn. If you look at the lower left-hand photo, you can see the embers and the burn marks on the roof of that house. So that house was almost ready to ignite, but they pulled the gutter off, and it literally stopped that structure from igniting. We also need to pay attention to fences. Wooden fences are a proven ignition source that can allow fire to travel right up to a house. The lower right-hand photo, again, is another photo in Paradise where the fence, you can see, was burning and was knocked down on the ground, and it stopped the ignition of that fence from burning over to the house. And so there were probably other factors involved with helping to prevent that structure from igniting, but certainly the fence was one of them. This is another structure that survived, and we look at the overall structure, but when we look up at the roof, we see that there were, pine needles and things that had burned on the roof in that valley, but the Class A roof covering did exactly what it was designed to do, and the combustible material burned, but did not allow the fire to get through the Class A roof sheathing and ignite the structure. It had the Class A vents, and then we look at examples of other homes about cleaning gutters, paying attention to the vents, cleaning the roof areas, and not having combustible material on the roofs. These are all going to make huge differences. I want to show you this structure very, very quickly. And this is where we look at details. This structure looks about as clean and non-combustible as you could think of. This is a structure that survived during the Atlas fire in the Silverado Country Club in Napa. A stucco roof, tile roof, a tile roof with stucco siding. But on the lower right-hand corner, you're going to see on the right-hand side of that house, you'll see a hole that was cut through that roof. And you'll see just above that hole and below the windows is a horizontal line of stucco, just a stucco detail that the house was built with. If I go to the next photo, I'm showing you the underneath side of that stucco line. If I go back to that photo and see that horizontal line, if you look up underneath it, you're going to see the exposed wood framing that was left open and exposed. And if you look at the landscaping along the bottom of that house, it was wood bark mulch. And after the fire had burned through, the wood bark mulch ignited, and then the heat radiated up to that exposed wood member underneath that stucco line and started the fire. And underneath in the crawl space, you can see that the wood joists underneath the floor in that house started to burn. A fire engine happened to be driving by and seeing smoke coming out of the bottom of that house, and they took action, cut a hole in that side, and put the fire out just before it ignited the entire house. So when we look at details on a house like this, you would think from just looking at it that it's pretty non-combustible, right? But it's these little details where you're leaving an exposed piece of open wood below an ignited, a bed of ignition of wood bark mulch that could ignite a structure. So it's all of these details that we have to pay attention with. And so I want to get wrapped up here pretty quick so we can address some questions. But in all of this, we are understanding more and more things and looking at people doing things right. But we look at why are so many structures still burning? Well, it's a lot of people are doing a lot of good work, and we've got some success stories. And how does this relate to any of you? And the main thing is because we haven't figured it all out yet. We are learning more and more, but we know that simply by relying on this, the fire department itself to have more engines or firefighters attacking the fire are not going to solve the question at overall. We're understanding the science better as organizations like the Insurance Institute for Building and Home Safety go ahead and study the ember ignitions. We're looking and understanding solutions from a better understanding of fire behavior and how that is impacting structures, as well as building design, building detailing, and long-term maintenance of a structure has huge impacts on the structure's survivability for the long term. And of course, also land use planning. Where are we building on the landscape? How is the structure able to be located so that it maximizes the ability to withstand that ember ignition after we get done? So overall, we need to look at this as an all hands on deck solution. We need to look at the architectural and engineering professions designing and building structures in a more fire-resistant way. Land use planning on where we're building in the landscape. The construction industry, the landscaping industry of how we're landscaping. The insurance profession, of course, has a thing to do with this as far as how they become engaged with structures in the landscape. We need to look at the smoke impacts and what that is, the impacts that those have had on people. Elected officials certainly have a lot to do with this in how codes are enacted and how we rebuild after fires. Neighborhood, city, and regional groups, fire-wise landscaping, fire-wise communities, fire-safe councils like the Fire-Safe Sonoma group, and then, of course, all of you as structure owners. The maintenance that you do, the work that you're doing in conjunction with your neighbors and your community are going to have a huge difference. And all of these things are the same whether we're talking about California or in Greece or in Australia or South America. There's communities all over the world that are having this, and we have to overcome the resistance to change the way we've always done business and continue to do things differently than we have before so we can increase that resilience. At the end of the slides, when you get to this PowerPoint, I've just put up a list of different organizations that have websites that you should feel free to go to that have a lot of really good information on landscaping and resources that you can look at. So this is, again, just a very short list of different groups that you can get to. And that's a big overview. I know that's a lot of information that I've thrown at you very, very quickly here. But I do want to give us time for some questions and answers. And on that, I want to turn it back to Roberta. I'm going to stop sharing my screen and we'll come back and start taking some questions here. So thank you, Roberta. Let's see how we go here.
Yeah, absolutely. Okay, so we have a handful of questions. They're rolling in. So I'm just going to start with the first one, and we'll just go through the questions. And I'm not going to read the name of who submitted the question. I'll just ask the question, and then we'll have you field it. So the first question is, how do I convince my spouse to respect the 5-foot non-ignition zone? At this time, there's lots of flowers, bushes, etc. Do you want to give that one a shot?
Sure. This whole notion of the 0 to 5 foot non-combustible zone around the base of a structure is clearly going to be very controversial. If anything, if you really if we're asking people to really pay attention to that 5-foot zone right around the structure, if I just tell everybody to rip everything out and put a non-combustible zone right around the base of your structure, let's face it, that really affects and alters your perception of what attractive landscaping is. Maybe I'm telling you that, for crying out loud, you have to tear out your grandmother's prize rose bushes or something like that. Even the research that we're coming up with isn't advocating that everything has to be pulled out, but you have to pay attention to what's there. You really have to look at where your openings are in your house. Do you have windows that you have heavy shrubbery and bushes underneath? And think about that. What would happen if those bushes started burning and then the heat and radiant heat is impacting that window opening? So thinking about where landscaping occurs, and have you reduced the amount of landscaping so that if embers ignite anything in that zone, is the ignition of that vegetation going to cause a problem with igniting your house? Maybe you've planted things there that are very highly fire resistant and they won't burn very readily or with a lot of heat. Or maybe you've done some non-combustible facing of the base of your house so that if vegetation along the base of that house does start, maybe it doesn't burn the house along the base of it. So there's a lot of factors that we can come up with. But it really does challenge the notion of what we historically look at and have accepted in our paradigm as attractive landscaping. And I would say that as we move forward, we're going to be challenging those perceptions of the way we've always done things, recognizing the fact that by changing the landscape around the base of a structure can really have an impact on reducing the amount of ember ignitions of those structures. So it is a learned trait, changing the perception, and also looking at very precisely exactly what you have and where you have it along the landscape. So I hope that gives you a little bit of information. And of course, there's more detail about that depending upon your particular house and landscape.
Okay, great. Thanks, David. So the next question, I'm going to put into like two questions in one because I think they're similar. And the question is, can you recommend a fire-resistant material for decks? And also, probably along those same lines, is there a way to make your wood roof more fire-resistant? I'm assuming this is like a wood shake roof. So let's give those a shot.
So I'll answer the wood shake roof question first. There are products out there that can be applied to wood shake roofs that can help make them less ignitable. But the problem with those are that there are no products out there that are going to be long-term successes. In other words, whatever product that you use to put on a wood shake roof has a lifespan to it. And it's a fairly short lifespan because of solar exposure and things like this. When you start getting into that heat of the summer and then you get rain in the wintertime, all of these factors are going to wear that roof down to the point where no wood additive products are going to have the lifespan of, say, a Class A roof material, whether that's asphalt shingles or metal or tile, or there's any number of Class A roof materials. Now, I will admit that there are Class A wood roof assemblies, but that assembly is quite expensive because it comes with the underlayment of type X 1 hour rated sheetrock underlayment. There's a very expensive process to do that, which provides some layer of survivability, but it's a lot more expensive than replacing with a Class A roof, I'll tell you that. So there's various things about it. So there are some products that you can look at and are touted as helping to reduce the impact of embers or ignition of wood shake roofs. But that's not going to be a long-term solution because the application of that has to be kept up, and the maintenance is quite difficult, I think, and very expensive and time-consuming over time. So your best bet is to look at a different type of Class A roof, which has a much longer lifespan to it and a higher resistivity of embers and ignition potential. As far as decks go, an interesting thing that we're learning about decks. A lot of people are looking at things that are non-wood decks, like the composite Trex decks, for example, just to use a brand name, things like that. Keep in mind the fact that those are not non-combustible. They still burn. In fact, if anything, they melt because there's a lot of plastic involved with them. One of the things that's really interesting that they've understood now is that decks actually are more combustible from the underneath side. So if you were to build a deck new today, there's almost, you want to look at the joists that are holding the deck planking on top of it. If you were to put a joint of either metal or some kind of non-combustible barrier between the top of the joist and when you put the decking on top of it, that actually has some viability of preventing the underneath side of decks from burning up onto the deck itself. I'm getting into some complex little details of things like that, and I'd be happy to share more later. I don't want to get into just an entire conversation of how to detail out a deck, but if you are replacing a deck, consider at the very least a non-combustible barrier between where the deck attaches to the house, so that if a deck is burning and it reaches the house itself, there is some kind of a barrier there that would help prevent the deck from burning into the house itself. So all of these things, again, thinking about a fire, just building a barrier that's going to help prevent a fire from burning into the house itself. Those are going to be helpful hints at trying to reduce the amount of fire from burning a house.
Okay, perfect. Now, it looks like there's 2 or 3 questions relative to maybe like instead of doing a whole remodel where you're replacing siding or something like that, do you know of any materials? Sounds to me like we're asking about coatings. Are there any coatings or materials, paint-like products, that you can put on your house surfaces to help prevent, fire?
Sure.
I'm thinking maybe, what first comes to mind for me is like intermittent paint. I know it's not technically, approved for California, but can you speak to that maybe a little bit?
Sure. There are a lot of products on the market that are sold as fire-resistant coatings. There are foams and gels and things like that that are promoted by the manufacturers that hypothetically are able to be applied, say, prior to when a fire arrives at a particular piece of property. But the difficulty of those are that they have found that they're very difficult to apply, to be quite blunt about it. Even in testing situations, it is very critical that those materials are very, very meticulously applied in a very thoughtful and detailed manner that have to be done throughout. If you think of a wildfire approaching your house, how, the time that it's going to involve of trying to coat your house with a fire retardant product is quite lengthy. Quite frankly, it's not done very, very quickly. And quite frankly, the speed of which we're seeing a lot of these fires arriving at people's houses after they're notified that a fire is coming is that you really don't have the time available to go ahead and adequately coat the entire house. If you do it a long time before the fire arrives, there is a time frame and a window that starts reducing the effectiveness of that product and things like that. So I don't want to get into any particular names because there are lots of products out there. And if you look at the testing of those products, there is the ability for those products to actually perform at some advantage to fire being exposed to that treated surface. But those are under ideal test circumstances. And under, real life circumstances, it gets more and more difficult because of the timing, because of wind factors, all those kind of things. And yes, I'll be the first to admit you can find examples. Every manufacturer can probably show examples of successes where their product was used and a house survived a wildland fire. I'm not going to stand here and say that they don't work. There certainly are circumstances where they can be valuable and they can work, but they don't always. And there's a lot of training and knowledge about how to use them properly to be able to do that. So we have a ways to go yet before we've found that perfect material that is easy to apply, that very quickly can go onto a structure using very little training and background and knowledge on how to apply it, and becomes very useful in preventing ignitions of that structure. So we do have a ways to go yet before manufacturers have really created, you know, that perfect material yet. I think that, you know, we're getting better and better at that. Again, looking at ways of building structures overall using non-combustible materials, for example, that can resist ember ignitions. Those are alternatives that certainly eliminate the ember ignition. So, you know, we are beginning to see more and more of those kinds of products and more ideas like that coming onto the marketplace. And insurance companies are looking at that and ways that they can encourage people to look at the materials they're using, the landscaping they're putting around their houses, the defensible space overall, for just not only individual structures, but entire communities. And all of those things are going to have an effect in a positive way on helping to reduce structure ignitions. So hopefully that gives you a little bit of generic information. Again, I encourage you to go to some of the websites on that one of those last slides I showed that can even get into more detail about that.
Cool. Okay, great. Thanks, David. So we're right at 4 o'clock. David, would you be we've got a few more questions in the queue, or would you be willing to hang around for, say, another half an hour to go till 4:30 to answer some of the questions we have in the queue?
Sure. I think we've got a little bit of time left. I don't know if I can go quite to 4:30, but I'll stay as long as I can.
All right. How about well, I want to have a hard out for the group so we all know. So how about 4:15? Could you go to 4:15?
Yeah, that would be great.
Okay, so I'm going to kind of pull the questions out that I think are most relevant to structural hardening. There's a lot of questions about lots of different things, and it's all important. And so the attendees know what I'll try to do. Like I mentioned earlier, this is our first webinar. I believe I can save the chat, and what I'll try to do is save the chat and the Q&A and kind of look at the questions and get back to you after the webinar to respond to your inquiries. So with that said, I'm going to work down from the roof, and there's a couple questions with regard to vents. So let's talk about the soffit vents. One question is there any value in swapping out your vents and going to the more modern vents or the fire rated vents if you have a wood-sided home? Can you speak to that a little bit?
Yes, there is still value. Even with a wood-sided home, you can take steps to help embers from impacting that wood siding. So there's a lot of different types of wood siding, whether it's horizontal shiplap, whether it's vertical board and bat. There's a lot of different types of wood and details that are used for wood siding. And so based upon the type of wood siding you have, you can use caulking at joints to go ahead and seal up any openings that can resist embers coming in. And so if you detail out and maintain your wood-sided structure in a way that embers are blowing up against that wall and essentially bouncing off, and you haven't allowed there to be any crevices or openings or cracks for embers to get inside and start igniting that siding, then yes, that ventilation opening and those better, newer vents are still very important, because that's the opening that enters into your concealed space. Whether it is your attic or your crawl spaces or things like that, it's important to maximize your efforts at eliminating the ability for the embers to get through those openings. And so even with wood-sided homes, You can, again, go ahead and detail out to prevent the ember ignition of the structure itself, but then look at those openings and make sure that you've put in the best resistance you can with newer vents that are ember resistant. Even the most highly ember resistant vents still may allow a couple of embers through them. But you want to, you can't guarantee that no embers at all are going to come through, but you can certainly reduce it. So yes, it is important to make sure that you're taking the steps to eliminate those embers from getting into those concealed spaces. So start with that.
Perfect, thanks. And then, so moving down from the roof to the soffit vents, we've got a question about windows, and I'm gonna kind of read between the lines with the question and ask. So if I've got, older style windows and I don't have the WUI windows, does it make sense to put like shutters that I can fold across those to block out the heat? Would that make sense? Would that be beneficial?
Yes, it would. They absolutely would. I mean, the interesting part is that we see people who live in hurricane zones boarding everything up. And of course, there are applications where you can have shutters that roll down across doors and windows and things like that. Those are all very effective. And, the luxury that hurricane folks have is that they can see it coming days and days in advance. Typically, we don't have that luxury when we have a wildfire situation. But if you had the ability to go ahead and close up your openings and cover windows and doors, again, that's going to be a big asset to help reduce any ability for, one, embers to get in and cause, impacts in that way, but also for there to be, you're reducing now the likelihood that any, that radiant heat is going to be significantly reduced and things like that. So if you've got the ability to create shutters or some kind of enclosure like that that would help block off single pane windows, even if it's double pane windows or multiple pane windows, that's going to be an advantage to you. So yes, those definitely can help.
Okay.
Roberta, I'm going to take just a short break for a second. I'll be right back.
Okay, sounds good. And I'm gonna kind of
go ahead and share some stuff. I'll be right back.
Okay. Let's see, I'm looking at some other questions here that maybe there's a couple I can answer. There is, mulch. Somebody asked about mulch. Let's see. Yeah, can I have mulch in my front yard as long as I have a non-combustible zone around the house? And so, I would say, to some degree, combustible mulch is probably going to be manageable outside your 5-foot no ignition zone. But still, you want to be careful. In my opinion, it wouldn't be too much different than having vegetation there. But at the same time, I would be leery of having any kind of wick or what I would call a fuse between that mulch and your house. So if you've got a good 5-foot non-combustible zone and then mulch outside of that 5-foot non-combustible zone, I imagine that, probably would help reduce your risk overall. Let me try another one here. What can we do to convince HOAs that every non-planted area of the yard to have a bark spread on it? Basically, this question, I think, is related to HOA requirements in general. And, I think anything you can do with your owners associations to create or modify your CCNRs to require things to make your homes more fire resistant would be good. I live in an HOA and we have a very restrictive set of CCNRs that do have requirements relative to wildland fire safety. So in general, I think anything you can do with your HOAs to make your CCNR is more robust. With that said, I believe that currently there's a movement afoot within our California legislation to make the 5-foot zone, non-combustible zone mandatory in California, but I'm guessing that's probably a year or so out in terms of how the legislature moves on things like that.
Yeah, interesting you should mention that, Roberta, because there is actually tomorrow a hearing by the Board of Forestry that will be talking about that 0 to 5 foot zone. They are looking at changes to the fire safety regulations for the state, and that is a conversation that is being held right now. So I think we'll see some iteration of it come into effect shortly, but you're probably right, a year, 2 years maybe, before we see it go into law.
Right, perfect. And then I do want to toss out that, you know, in my opinion, one of the easiest, most economical things a homeowner can do to help reduce their wildland fire risk is go out and get a couple tubes of caulking and run around there and seal up all those nooks and crannies around your home. Doesn't cost a lot, you know. I think sometimes you can even buy either at the hardware stores or even online, you can order caulking in colors that you can get close to your color of your home. And I also think for a little extra money, you can get caulking colors that'll actually match your paint color. So yeah, so what do you think about that, David, in terms of being a real quick, down and dirty, easy fix overall?
Yeah, I think those are really good suggestions, and a lot of caulkings are paintable, so even if it doesn't match your color, you can paint it to match. So yes, those are good examples. Another good example on that same thought is around your garage doors. If we all think about it, garage doors over time going up and down get very loose, and we have learned that ember intrusion into the corners and around garage doors, which get loose and open up with gaps, are a very common cause of structure ignitions. So that's why today, in today's codes, there is actually a requirement for a much thicker insulation or foam sort of, or non-combustible material actually that goes around and seals the edge of those garage doors. And as probably a lot of you know, one of the requirements for new garage doors today is to have a battery backup. Because unfortunately, we discovered that there were a very high number of fatalities in recent fires from mostly elderly people who were unable to raise their garage doors after the power went out. So today, if you replace your garage door with an electric garage door, it is required to have a battery backup. Ironically, one of the things that some of these garage door manufacturers and companies are telling us is that the majority of people coming in and buying those garage doors are not because they're replacing or upgrading. It's, well, I guess they are upgrading because people are coming in and asking because they want that battery backup. And so the majority of their sales are from people not with new ones, but for people upgrading. And so that is, that went into state law on July 1st of last year. So that is a new requirement that if you're going to be buying a new garage door today, you have to incorporate that as part of the new garage door.
Well, I did not know that, so thanks for sharing that.
Yeah.
So in the interest of time, I'm going to move down. I want to make sure that we cover the key elements of the structure. We talked about roofs, we talked about windows, we talked about siding, we talked a little bit about soffit vents. So let's talk about the crawl space vents, you know, and I think a lot of what applies to crawl space vents will also apply to soffit vents in some of the areas we didn't talk about and some of the questions I'm seeing. So one of the big questions is, you know, the current code requires 1/8 inch mesh, old code was 1/4 inch mesh. So does it make sense to retrofit your current 1/4 inch vents with the 1/8 inch? And if you can, you know, speak to vents even more broad in scope, that'd be good.
Sure. So if you have an existing vent that has a 1/4 inch opening. I mean, at the very least, if you went to buy new mesh that is at maximum at least no more than 1/8 inch openings, and just put that over your 1/4 inch openings, that would help. It's not going to eliminate or reduce the amount of embers, but it will reduce them. So it's not going to completely eliminate them. But that's a pretty inexpensive way of just simply putting a tighter screen mesh over your existing mesh that would help go ahead and improve the situation that you have now, without having to go to the expense of buying an entirely new screen to go ahead and device to go ahead and put in. So there are ways that you can go ahead and upgrade or retrofit your existing situation that improves your likelihood of reducing that ember ignition potential. So even those kind of things are simple, inexpensive ways that you can look around your house, and certainly maybe looking at your vents and maybe making sure that they're again, you don't have a lot of heavy fuels or combustible loading right in front of them that would burn and allow embers to maybe blow into those areas. Again, it just looks at your circumstance, and think about being in an ember storm with those heavy winds blowing embers onto your structure, and what could you do to try to reduce those embers from igniting anything on that structure, whether it's on your roof, under your eaves, on your siding, on your decks, underneath your decks, all those kind of things. Just really think about the ignition component of anything you have around your house, and then helping, really reduce that ignition component.
Yeah, one of the things that I am telling myself that I'm going to do in the, lead up to having to evacuate is I went and purchased a roll of that heavy duty aluminum duct tape. And I've convinced myself that when I get the order that I'm in the queue to evacuate, not that I'm ordered to evacuate, but when I'm in the queue to evacuate, my plan as part of my set portion of my Ready, Set, Go is to quickly run around the house with that aluminum tape and tape over my vents with that tape. And I'm curious, David, is that a good idea? Do you think the tape will hold under the heat conditions we're likely to see? I don't know if that's just, goofball idea or good idea. Can you talk about that?
I'm going to say it is not a goofball idea. I think that those, to be honest, I've known actual people who've done that kind of thing. I'm going to start out here by saying there is no testing or direct scientific evidence that that is an effective means of saving your house. I would say that it can't hurt. So I don't want to discourage anyone from doing that kind of thing, but there is no way you can guarantee that that's going to be the magic bullet that sort of saves your house. I think there is evidence of those kind of things helping to reduce embers from getting into those spaces and things like that, because you've now basically blocked it off. But let's face it, those tapes have not been scientifically tested in a laboratory setting. We don't know how much time they can be exposed to heat before they get rendered ineffective or peel off. I just don't know the details of any of that. I don't think anybody does because we just haven't gotten there yet. Those haven't been tested in that manner. But I know people who have thrown that idea out there, and I don't want to dissuade anybody from taking that action because, quite frankly, it's another step that could help. But there's just no guarantee about it.
Right. So it's not FDA approved.
It is not.
But for a compassionate use, it might be effective.
It might be. There's, you know, and I, you know, it would be wonderful if you came back and said that I did this to my house and I know that that's what saved my house. Well, great. You know, that's,
Yeah.
that's fantastic. But, you know, we just don't have enough scientific evidence to support it right now.
Hopefully I won't have to do that. So we are way out of time. We're bumping up against 4:20. So I'm going to thank you, David, very much for doing this.
You're
I'll be
welcome.
talking to you a little bit offline, maybe do this again down the road here, because clearly we've got a lot of interest.